My last video cut me off before I got the answers on here. Sorry about that, guys. But here are the answers to these log questions. I do want to point out real quick, we had two undefined answers because it was specified earlier that x could not be negative. Okay? You cannot have a negative argument. So those both came out with errors in the calculator, which makes them undefined. So look at graphs of logarithmic functions next. In order to graph a log function, we have to recognize, or it helps to recognize, the relationship between a log and an exponential function. Okay? So what is the relationship between y equals log base a of x and y equals a to the x power? Well, if you remember right, back when we did inverse functions, you switched your x and y values, and then you solved for y. So if I took my first function here, y equals log base a of x, and I swapped my x's and y's, and I had log base a of y. By the way, I never put this on there. I'm always behind. The log is always on the left. So this time if I switch my x and y, I would have this. Now, if I solve for y, that means I want to convert this to an exponential. So all about that base, circle around, equals the argument. So y equals a to the x and y equals log base a of x are inverse functions. Inverse functions means that all of the x and y points are swapped. So in other words, if one of those functions had a point at 2, 4, the other one would have a point at 4, 2. So we already know what 2 to the x looks like. We already graphed it, talked about it. But let's look at it here before we go to the calculator. We know that 2 to the x rides a low along the x-axis here, crosses at 1, and then goes up sharply, right? So it rides low along the negative part of the x-axis. So this is 2 to the x power. If I want to look at log base 2 of x, instead of crossing the axis, the y-axis at 1, it's going to cross the x-axis at 1. Instead of riding close along the negative x-axis, it's going to ride close along the negative y-axis. Instead of increasing upward quickly, it's going to increase to the right quickly. So this is log base 2 of x. Another characteristic of inverse functions is that they are a reflection of each other over the line y equals x. So if I fold it along that line, these two graphs should match up. Now keep in mind that I drew those by hand, so they probably wouldn't be perfect, but you get the idea. If we were to look at Desmos, let's go back up here and put y equals log base 2 of x. Sorry, my screen doesn't want to take my information here. X. And then let's do y equals 2 to the x power. And then I also like to see it, y equals x, and I usually change it to a dotted line so you can kind of see that that's how the inverse functions work. Okay? All right. So, sketching the graph of a logarithmic function. I want to sketch the graph of y equals, or f of x equals log x, and identify the vertical asymptote. We haven't talked much about asymptotes in this section yet. Log of x is log base 10, right, of x. It's going to come up here, it's going to cross right here, and it's going to go this way. This has a vertical asymptote. The right-hand side, a lot of times people think that this is going to have an asymptote, but this is going to keep going up and to the right. This is going to go down, and it's going to try to approach the axis. It's not going to go across. So what we have is a vertical asymptote right here at x equals 0. To find this, you set your argument equal to 0 and solve for x. A lot of times you can kind of check it on your graph. All right, let's go ahead and I'm going to back out of this video and we will come back to our graph characteristics next.